Welcome. Today we are going to take on telephone. So this is challenge number 4. And in this challenge, our main goal is to take ownership. You can see it right here at the top. It states, claim ownership of the contract below to complete this level. Things that might help. And it basically says go beyond console in the help section. So if you go to the help section here and go to beyond console down here, you'll see that it basically states that we should either use Remix IDE or Truffle framework. We're going to use Remix because that's easier, at least from here right now. And I wanted to tell you, Internet, this is a great level. This is a great level because I didn't have to cheat. You know, we have this video series that's been helping us along, and I'm sure it'll continue to do so because I'm sure a lot of the challenges are too difficult for me to continue on, but I'm proud to say that I was able to solve this challenge without his help. I did watch his video, and it was very useful, and I'll recommend it for you to watch as well, but I just want to let you know, we did it. We did it without cheating. And this is what my face looked like when it worked. I was so astonished. Anywho, let's get into this. As per usual, we have a lot of notes that I'll walk you through. First things first, though, we're going to go backwards, and we're going to check out the challenge, and we're going to review the code. So the code snippet here is quite small, which is nice. And I think what I'm going to do here is I'm going to do something similar to what the other YouTuber, blockchain developer guy, I'm going to walk you through kind of what the attack was and what we're doing here. Now, with this challenge, we're exploiting a very specific thing. And that specific thing is tx.origin. So if I zoom in here, you'll see there's a specific mention of tx.origin. This here is recommended to no longer be used. Reason being is that you can actually run an attack, which is kind of like telephone, which is, this is really good naming, kind of really good naming for people to kind of think about what this means. Now, I'm gonna share some diagrams that'll hopefully make this resonate a bit better. And before I do that, should we walk through the code first? I'll quickly show you the diagram, and then we can walk through the code. All right, here we go. So this diagram is going to help us understand specifically what does this actually mean. What we're looking at is tx.origin, and another method or item to call is msg.sender. Now, the basic takeaway from this is never to allow tx.origin to represent your ability to authorize someone to do something. It should always be msg.sender. Reason being is that transaction.origin looks at the entire call chain, and I reference that here as well in this example. But at a high level, we'll kind of go through all this later on, so let's just quickly look at this. So if you understand this, message.sender is an account address, it's an account address, but it also could be a contract. Transaction.origin is always going to be an account address. So this is always going to be a human. It's our human. And message.sender can sometimes be a robot. That's my robot face. And that's going to be your smart contract. So it could either be a smart contract for message.sender, or it could be a human. Now, this is an example here. So we have an account, and it's moving into a smart contract. Here we have another account, and it's going into contract A, which then goes into contract B. So contract B is going to interpret the message.sender as contract A. And you can see that here. So message.sender equals contract A, because message sender is referencing the most recent call. It's not going to the very origin, hence the name origin. It's not going to the origin of the call. But transaction.origin is actually going to see the account address as the original caller. It's going to go past contract A into the original contract. And that's kind of a really important piece to understand here, and that's what we're going to manipulate and leverage in our own way to gain control of this contract. With that being said, let's get into the code. I have a few bits of code here. So Web3 blockchain developer, in his YouTube video series, he actually explained this specific attack down here before he jumped into the challenge code. Reason being is the challenge code is quite simple. And with the code being simple, it's kind of hard to understand and interpret how this would be leveraged in the real world. And there's tons of links that I'm going to share with you that talk through this specific code set. So I won't dive deep into it. I'm going to give you 2 videos and also a write-up that explain it probably better than I can. At a high level, I'll explain it to you here just so you get an intuitive understanding. But this attack is very similar to cross-site request forgery if you know anything about Web 2 kind of application security stuff. And if we come down here, we have two contracts. And we're basically going to try to phish the target. That's our goal, is to phish the target so the target does what we want them to do in a roundabout way. So let's go through the code really quick. Here we have contract wallet, and then down here we have the attack contract. Now the attack's going to obviously attack the wallet here. So first we have a state variable, which is the address, and that's the owner. This constructor is basically whoever deploys this wallet on the main net or on whatever network, that's going to be the owner. You can see that's sitting here in the constructor. So this constructor is going to be payable as well. So we're setting the owner when we deploy the contract, and this is our main function, which is transfer. In this function, we have a few things. So we have a to address, so who are we transferring it to, and the amount we want to transfer. Additionally, we have a require statement, which is what we've talked to previously, is that it's basically requiring that the origin, it has to be the owner. So the transaction origin has to be the owner if you want to actually transfer anything. And down here, I've added some notes here because this bit was slightly confusing to me. I knew what was happening, so I had an idea that, okay, we're sending a specific value to the address, and if it's not true, then it's gonna fail. If it's true and it's sent, then we'll actually send the money. But I was kind of confused by this piece here. I didn't know what this meant, and I didn't really understand the syntax. So to take a step back and share some resources with you, if you're kind of confused by that small snippet and you want to know specifically what's happening there, is I have it cut out here, that code that we just discussed, and I have a few links here that actually helped me understand and intuit what was happening. So first, this Stack Exchange write-up, basically this guy had the same issue 10 months ago, and he was like, I don't understand what's going on, and kind of explained the question, and I think actually answered his own question, which is like, 100% kudos. I love when people do that. And here you can see basically they break down the explanation, so I recommend reading that. Reading that actually led me to another link that explains further in detail what was happening, which is in the Solidity docs here, and that talks through the call and the low-level call piece here. And then the other one I'll link you to is going to be another thing that led me to this conversation, which shows you the changes that happen in Solidity.50, I think it was. Yeah, .50 and above that actually incorporated this. So let's walk through what it is, and then I'll show you some of the resources. And I think to do this would be better if I showed you the resources themselves that explained it. If we come down here, we'll see that a few things are happening. The first thing is we're calling the address. So for that's going to be us. That's going to be 2 for us, and that's basically the address we're sending it to. This call function is a low-level call, so it's kind of risky, but I think from what I could find, they recommend that using call as one of the safer methods of sending Ethereum. There's a few items you can put in here. So in the curly braces here, I think there's 2 parameters that you can put in here. You don't have to put them in a specific order, and you can include one or not include one. And that's basically stating how much value you want to send. So how much ETH you want to send here. And they're basically placing that in the message.value. And then also you can state how much gas you want to send. So you can set a limit on how much gas you want to send for the additional executions that have to occur if you're sending it to a smart contract. Last piece here is a confusing piece that I got confused by, which was why did they put basically a blank string in there like this? What does this mean, and why would they do that? Well, if they didn't do this, traditionally what would happen is they would include the ABI encode with signature or some other variants of that, and then they would actually call out a specific function they want to leverage. And you can see that being mentioned up here in this section, where basically this example here, you can see they're calling out the foo function in another contract. These are the parameters they want to pass or they want to interact with. And then you can see that this is the parameter they're passing into string, and then this is the parameter they're going to pass into the UN. So if you know the specific function you want to call on a contract, then you would have to interact with the ABI, and you would encode that with the signature. But if you don't know what you're interacting with and you just want to send Ether to a contract, almost all contracts are going to be able to accept Ether if they have either a receive or a fallback function. And when sending it, you have to include the quotes like this because it only accepts, I think it states single byte arguments. And if you don't pass this in, then if you don't pass an empty string, the compiler will throw an error. You can see that mentioned there. And that kind of made sense to me. I was like, okay, so it has to be a single byte argument. Not really sure what that means, but we can dive into that further. So that's when I dove into this documentation here, where basically it walks you through, I'm not sure members address, how this is relevant, I'm sure it is, But you can see they're basically talking through some of the stuff I've just mentioned, where the functions that you can call inside of the that section is either encode, encode packed, encode with selector, or encode with signature. And that's if you know the function. But if you don't know it, then you have to send it as empty. And if you send it as empty, then you can see you're basically saying that it only takes single bytes. So I'm assuming when something's encoded, it's in a single byte size. And additionally, if we go here, and you see the breaking changes for 0.5, yeah, 0.5 and above when they did this, they talk about something similar. So a lot of what I mentioned previously is discussed here, and you can see basically here they state that the changes that were made improve the ability for the arguments to be concatenated, but also you can see the changes that they made are stating that basically every call has to now include these, and every call that has a signature and parameters, etc., has to include the ABI encoding here. And I think they did single byte memory because there was a mention of a 4, I don't know if it's here. There's something that mentioned around byte 4. There's a piece of documentation I didn't save, sadly, that talked about how they've changed it from a 4 byte to a single byte. Reason being is I think there was some sort of attack that was occurring and impacting their ability to prevent it. I'm not really sure if I can, here it is, okay. So previous versions of Solidity allowed this function to receive an arbitrary arguments and would also handle the first argument type of bytes 4. The edge cases were removed. So I think there was edge cases here that would allow this, that might have been exploited previously. Either way, these resources will help you understand a bit more about what this specific code snippet means and specifically what's this referring to here. All right, now that we've gotten past that, we've talked about our wallet, we know what's happening here. So we're establishing an owner, and we're doing a few other things that are pretty common for most of these editors we looked at so far. Next, we're going to look at our attack contract. So our attack contract is establishing another state variable, which is going to be the owner, and that's going to be the address. And an important thing here is that it's going to be payable. So when this call is sent, there is a payable variable in here that can receive Ether. We're going to call that contract, so we're going to take that contract that we're interacting with the target, and we're going to place it into a variable called wallet. Our constructor here is going to include our target address here for a wallet, and you can see that we're placing that into a variable, so we're going to instantiate or kind of initialize this wallet and place that address in there, so when it's called. And also the owner, us, when we kick this attack off and we put it into the network and we kind of deploy it, we're going to be the owner. You can see the sender, that's going to be us, and it's going to be payable, which is really important so we can actually receive the Ether. And then below that's the final piece is the actual function doing the attack. So what we need to do here is we need to trick the target user into interacting with this function so we can then siphon off all their balance. And the reason we're siphoning, and we know that, is in the function attack here, we can see that we're calling the contract, we're calling transfer, we're the owner, remember, because we established that here, and we're basically going to say we want the entire balance of the wallet to our address. We're going to siphon all that off. But as I mentioned previously, we need to trick this user into, basically, we need to fish them. We need to fish them, which is old school weighing that if we can trick this poor soul here into clicking this button, that button is actually not what they expected. So maybe they thought they were, ordering a pizza, but instead they actually ended up, interacting with our attack function. And when that happens, that's going to come back to our function. That's going to initiate this, which then makes them the origin, but we're the sender because they're going through us to their contract to initiate this so the funds are siphoned off. So when they look at this requirement, the origin is going to be our, sad person here that interacted with us first, but we're the sender. Remember, so that was message.sender. That's going to be us, but they're not checking for the message.sender, they're checking for the origin. So that means that they think that the origin is the owner because it is, and that allows us to siphon off all the funds here for the transfer. I hope that was understandable, and I hope that was useful because we're going to do that here in our contract. But before we do that, we'll run through some of the other resources so I don't forget them. All right, so like I said last time, we're fishing, and this is a pretty simplistic and decent write-up on the topic. There's not much explanation here. It's really just a snippet of code the code I just walked you through, and it's a lot of examples you'll see that use this code for the wallet and the attack. some explanation of what's happening here, and they kind of share some links here that are useful to read as well. So that's one way of showing how you can fish through the transaction.origin method. Another example here, which I thought was actually a higher value. I thought this was a better example, mainly due to the fact that they explain more. They're not just necessarily pointing you to certain things and saying this is the code and read it. And also they give you a lot of additional reading resources here, which is always nice. I don't want to save that. So this is another one you should read that kind of gives you a walkthrough of what the attack is, why transaction.origin is a bad idea, and specifically how it's vulnerable. So if we come back here, in this text here for my notes, I'm basically stating that the key here is that we need to trick the target into clicking our button so we can siphon off the funds. Some additional resources. So I highly recommend, this is my preferred video that walks through transaction.origin and how it works within phishing. I just think that this YouTuber does an amazing job at explaining technical topics. But like I said, the web developer, Web3 developer guy, he did a great job at explaining this as well. He both walks through that contract as well as the contract we're going to walk through for the challenge. All right, so we've kind of talked through the difference, but I'll highlight it some more here, and also some valid uses for this specific item. Because when you read all these blogs on how transaction.origin is not useful, there's at least one valid use case that I've seen. With that being said, I think there is a blog out there with Vitalik saying that you shouldn't use transaction.origin because it most likely or potentially could be deprecated in the future. With that out of the way, the one use case I've seen that is useful is specifically if there are external contracts. You can deny external contracts from calling your current contract by basically implementing a required statement saying that the origin has to be the sender. Now what that means is that only I can call my contract. And this would happen during the beginning of the contract, at the very beginning. So we're not doing authorization here for transfers and things like that, but it's at the very initial stages. So when you do deploy this contract inside of the constructor and you state that the only person that can call this contract and interact with it has to be me, the origin of the account, that's one of the valid use cases I found. Another idea is basically creating allow and block lists. So instead of doing authorization, you could check and see specifically what address is calling out, and you could block or allow that contract based off of a whitelist or a block list. And another thing is tracking. So you can actually keep track of the origin and the counter associated to it. So you can kind of keep a tally of how many times a specific address has interacted with your contract over time, because maybe there's an address that's interacted with your contract way more than the others if you look at the overall aggregate over time. And this may be either something you want to act on in a positive or a negative way. So those are some of the valid reasons I've found that this might be useful. And this, I think this blog here, this blog here kind of walks you through some of those valid use cases. And as per usual, we'll link it below, as we do everything. All right, differences. So we've talked about this, but I want to talk about one specific piece that really jumped out to me. And that's going to be the piece where we talk about the owner here. So msg.sender, the owner can be a contract, but the transaction origin cannot be a contract. It has to be a human. And the other really important piece here is the piece I've highlighted here, which is most recent and full chain. As we mentioned here, the msg.sender refers to the most recent call, and the transaction.origin encapsulates the entire chain. So here in this example, we only have 2 calls, but this could be, this could be 10 calls. So you could have another contract here and here and here and here and here. But the origin, transaction origin, is going to always be this one way back here. But the msg.sender is going to be the most recent one that happened. And the last piece here is, as I've talked about, this really is an encapsulation of an old school attack called cross-site request forgery in Web 2 applied to Web 3. And if you're not necessarily sure of what this is and how this works, it's basically when you have an attacker, and that attacker basically forges some sort of request to fund so an example here is funding transfers to their website. So say you're looking at a banking site, and the banking site is bankofamerica.com, but this attacker has basically created another website that's bankofapples.com, and they've tricked you into seeing that the website is identical to Bank of America, everything looks the same, but Bank of Apples is actually Bank of Apples, and it's a typo squat, and it actually behind that website has probably some sort of JavaScript set up. So when you click a certain button, you've maybe already logged in to Bank of America previously and you're going back to Bank of Apples. And when you do that, what this attacker can do is they can actually utilize that click and divert it back to the original website. And when they divert that original click to the website, they can then transfer all the funds to themselves if they've set up a specific, usually some sort of JavaScript saying that I want to transfer all my funds to this attacker, without knowing that you've done that by incidentally clicking a thing that you've been kind of socialized or fished into. And that is interesting. And the main takeaway, as I said, never use transaction.origins for your authorization. All right, with all that out of the way, let's solve the challenge. We've understood what's going on, so let's actually do it. Here's our contract. So this is our target that we're attacking. And let's make it a little bigger. So in our target, per usual, we have a few items here. So we have our compiler. So our compiler and the compiler we're using is .8 and language is Solidity.8. And our contract is called telephone. We have a state variable for an owner that's an address. We have our constructor, which basically states that the person that deploys this contract is going to be the owner. So when you deploy this, the sender is going to be the owner, so that's going to be the owner of the contract. And then we have our change owner. So remember, our goal here is to change the owner. We don't have to transfer any funds, so it's a lot easier on us. So really all we have to do is ensure that we can actually call into this change owner, and then ensure that if the sender is not the origin, then decline. If it is, then give them the ownership rights. So now that we understand kind of what's going on here, we're going to show you the attack. So the attack here is a few things. So as per usual, we have our compiler here. We're going to import the other contract so that we can actually call it and interact with it. Additionally, we have our contract here, attack. So you can see that we're basically taking the contract telephone, putting it into this variable here of telephone contract. Our constructor is basically calling that address. So when we deploy this, we're going to call our target address, and we're going to put it into this variable here. And additionally, we're going to basically interact or initialize that contract, place that address inside of here in this variable. And then we're going to run our attack. So our attack is going to be very simple. So we're going to basically say attack public. We're going to call this variable that contains the initialized contract with the address. Then we're going to call change owner, and then we're going to put the sender. The sender, as per usual, is going to be us. So if we go back here, let's do some stuff. So if we open this up and we make this, clear this out, we do contract, and we can see that our ABI is a few things. So we have all the stuff we've already discussed. So we have the constructor. Didn't mean to do that. We have the function for change owner. We have the owner, which is the other function. So the owner bit it's a free getter. I think it's what they call when you put something that's public like that. So if we do this, we can see the owner is 0B6, and we are not 0B6. We are 03D. And if we do another thing here, so if we do, I think, let's do change owner. Let's just try to change it from here, and we'll see it error out because we are not the origin. Just to show you that you can't do that. Error, no dice. And what are the other methods? Yeah, those are really all the things you can do. All right, so let's go to Remix IDE, and I've already have everything set up, so we've already kind of discussed it. So we have our smart contract we've discussed, and we have our attacker contract we've discussed. So now what we want to do here is we want to compile both of them. So we'll compile both telephone and attack, and it's going to give us the same error about the constructor being public. And once we've done that, we want to do inject web3 as per usual, and that should bring in our address. And we want to deploy telephone, the victim, and then we want to deploy the attack. But to deploy the attack, we need an address, because remember, we're targeting a specific location, and the address we're targeting is here. You can see that if we just do await contract address, it's going to give us back the address of the contract we're targeting. So we'll place that inside of here, and we'll do deploy. We'll give them our Moonies. And I think it deployed already. That was pretty fast. So I think I still have to call attack because we've not really done anything. We've just deployed it. Yeah. So now that both of these are deployed, we just want to call the attack function. And once we call the attack function, then what it should do is, since we're the sender. We're going to call change owner, and that should basically kick this off and do what we want it to do. Huh, look at that. It's so fast. I don't know how to do this fast. So you can see that we are the owner now because of the finagled stuff we've done here. So we basically said sender, change owner. When we've done that, we've basically mimicked and impersonated the piece here. So we're not the origin, so we changed the owner. So if we submit the instance and wait 5,000 years, we'll see that we've won. Congratulations, we beat the level. And here it just explains a bunch of stuff that I've already explained. You can read through that and click some links and learn some more. But with that being said, telephone is done. I'll see you in token.